imagine a future where we don't have to mine anymore, right? But where we talk about asset management, where we take things out of a shelf and move them from one building to the next after their use cycles. And so it's designed for disassembly, it's designed for reuse. It's really taking a holistic approach to a circular construction industry.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. Welcome back to the Passive House podcast. This is the last of our series in circular building and construction. I'm joined today by Mary. Mary, good to see you.
Nice to see you, Matthew.
And also Ilka. Ilka, how are you doing?
I'm doing well. Thanks.
And we're just talking about the fact that it's pretty warm in your part of the world as we're recording this just before July 4th, and meanwhile down here I'm pretty cold with ice on the car, but that's the way we roll. We're going to get stuck straight into this interview today. Great conversation with Felix Heisel, who is an assistant professor and also director of the Circular Construction Lab. He's based in New York. But before we get into that, let's do a quick shout out to our sponsors for everything at Passive House Accelerator. Thanks very much to our stakeholder partner, NYSERDA, and founding sponsors 475 High Performance Building Supply, Glavel Foam Glass Gravel, Ingui Architecture, Minotaur, Partel, Rockwool, Stowe, and Zola. And champion sponsors Buizo, Gradient, Icon, Intelligent Membranes, pH Air Seal, and Source 2050. Ilka, you first met Felix, or you first heard him speak at a conference?
Yes, I heard him speak at the first part of the one of the New York Passive House events last year, and I was just fascinated by what he presented, and just kind of really reshaped my thinking towards materials and towards just how to look at building buildings that might be reused in the future. So I just thought it was fascinating.
It certainly was. Great conversation. Well, let's jump straight into it. This is Felix Heisel of the Circular Construction Lab.
Welcome to the Passive House Accelerator podcast. We're really excited to have you here, one of the pioneers of circular construction. Can you tell us a little bit about yourself and what you do?
Yeah, thank you so much for inviting me. My name is Felix Heisel. I'm an architect, and I'm teaching at Cornell University in the architecture department. And I'm also directing the Circular Construction Lab, which is my research unit at Cornell.
Great. And can you explain the term circular construction and what it entails?
I think it's easiest to sort of zoom out a little bit and start with the circular economy, which really tries to close the loop and design waste out of the system. And so if you're trying to apply that to the built environment, then there are two directions that is worth looking at. One being the past and looking at all the buildings that have been built already, sort of trying to understand what do we do with those? How can we understand these buildings as a resource for future construction? And then looking towards the future, trying to figure out how do we build differently from now on so that the buildings in the future, when they get to the end of their use time, don't run into the same problems that we see with the current built environment. And so now if we look at these terminologies, then the first one is more considered urban mining. So it's the question, how do we access these materials, these resources? How do we, first of all, estimate how much material is in a building? How do we then develop technologies and techniques to get these materials out at their highest utility and value for a next use cycle? And circular construction is the other side of that. It's imagine a future where we don't have to mine anymore, right? But where we talk about asset management, where we take things out of a shelf and move them from one building to the next after their use cycles. And so it's designed for disassembly, it's designed for reuse. It's really taking a holistic approach to a circular construction industry.
Yeah, that's so interesting. And I know that there's quite a bit of talk about this in Germany. And we are interviewing Anja Rosen, who came up with the Urban Mining Index, and then also Dominic Campanella, who started Concular. So those are two ideas of how do you deal with the, first of all, with quantifying what we have to work with in the future, but also guidelines on how to actually construct right now so that we are ready for the future or for the next life of all those building materials. So I think that's something that's really, really interesting. And with regards to embodied carbon, it's definitely the ultimate approach, right? So, and you have worked in a variety of different countries and universities, and then you came to Cornell and started the research lab. So what is your path towards the research lab? Where did you work? Where have you taught? And then, when did you start the research lab at Cornell?
It's actually been quite a journey. So after graduation, we went to Africa. My first teaching job was at the EIABC, which is the Ethiopian Institute of Architecture, Building Construction and City Development. And it was a really forming time for me to, on the one hand side, of course, in terms of teaching, in terms of a new society that I was invited into, but also in terms of an understanding of material resource availability and complexities that are maybe not as obvious in terms of supply chain issues, for example, and the larger global context in that our construction industry is embedded in, right? And then from Ethiopia, we moved to Singapore, which was a kind of 180-degree turn in many of these aspects, but specifically in terms of material value and waste generation, recycling and reuse. And so these two very different contexts actually influenced the writing of a book, which came out in 2014, which is called Building from Waste. Which I co-authored with Dirk Hebel and Marta Wiśniewska. And that book, in the end, I think had quite a significant influence on where I am today. Because on the one hand side, it sort of sparked an interest by community partners that asked for demonstrator buildings like the Urban Mining and Recycling Unit, but it also led to teaching positions at Cornell, where I was invited to teach a studio on waste in 2017, and then eventually got appointed as an assistant professor in 2020.
That's great. And well, that's a very different climate from Singapore and Ethiopia.
Yeah.
And do you still practice in Germany also, or you're solidly based at Cornell and not straddling the continents anymore?
No, I am a partner of an architecture office which is based in Freiburg, in Germany, with two partners, and all three of us are professors at three different universities, and we understand that office really as a vehicle for full scale research and implementation. So it's whenever the university can't take on the last step of a project because you need an insurance, you need to have the ability to sign a plan or to stamp a plan. That's where this office then steps in and takes us to the full scale implementation of these projects. But that is sort of the main interest. How can we actually build circular? So the office is really an extension of our three research units.
Yeah, and that's so important to connect those two, right? Because the research is one thing; it's like these theoretical ideas, but then it really needs to get proven in the field, right? Especially with construction. I mean, that can be fairly hard. So what do you do within your lab? Like what do you focus on, and then how do you translate that into the real world?
So the Circular Construction Lab is a interdisciplinary research unit that is housed within the College of Architecture, Art and Planning at Cornell University. And we're mostly involving undergrad and graduate students from right now anywhere between architecture and biology, mycology. We have a couple of economists, planners. So really a diverse field of disciplines that are coming together to tackle questions of circular construction. And the research projects are then equally diverse. So we're talking about can we build with mycelium in one project, or how can we change policy across different state level and municipal levels in others. And we're developing software tools to actually really give helpful tools to students, but also the industry. And all of this has to do with the ambition to scale circular construction. Right? So we're at a point where we're saying, I think we've built enough demonstrator buildings to show the feasibility of circular construction. It is possible, it is doable, it is economically feasible if you do it right. But it hasn't reached sort of a common status quo implementation in the industry yet. And so all of our projects that we're doing in the lab have to do with this question in mind: how can we scale it? So what kind of tools do we need to give to the industry to make the implementation easier? Or how can we implement policy change to support industry in the scaling of circular economy ideas and principles?
Wow, that's such a broad aspects of the whole circular construction world that you're working on simultaneously. To help our audience understand maybe more specifically a project that you've worked on or a policy that would support circular construction, do you have any North American examples that you could talk about?
Yeah, there's sort of two questions in one. I'll go, I think, the reverse order. So if you ask about policies that are existing in the North American context, recently we've seen quite a few deconstruction ordinances that have been implemented. This started with a ordinance out of Portland, Oregon. I think it was in 2016 when this idea came up for the first time. And the concept essentially of a deconstruction ordinance is to mandate deconstruction over demolition. And so this doesn't mean that you're you should always go for building reuse first, then you should do adaptive reuse. But if the last resort is demolition and landfill, then the deconstruction ordinance kicks in and says, no, you're not demolishing this, you're deconstructing this building. And the purpose is that a careful deconstruction keeps the material value of the elements in a building intact, right? Versus a demolition, if you go in and an excavator just eats up that building, just the mechanical process breaks the elements, mixes materials into one dumpster, and with that reduces any possible reuse or recycling scenario. And so by carefully disassembling a building, right, you're retaining these values and you're preparing a path to a next use cycle. And so this was quite successful in Portland and has been adopted now by Palo Alto or San Antonio. Boulder in Colorado has an ordinance, and the most recent one that we're aware of is Auburn, New York, which is also the first deconstruction ordinance in New York State, or it's not an ordinance yet, it's a resolution. But it is, I think, paving the way to a different type of understanding of the value of our built environment. And in terms of your second question, how are we involved in this, or what kind of project could be exemplary of their work? That actually is very closely related, because one of the projects we're working on right now is a white paper that we're writing as a larger coalition funded by the Atkinson Center for Sustainability. And this white paper is directly targeted, so to say, to New York State Assembly members and senators to give them sort of the background and the data for more informed circular economy policy adaptation or drafting and then implementation. And we're working very closely together with our local representative, Dr. Anna Callis, who has already proposed several of these new bills. And we're really hoping that white paper is going to propel additional policies on the state level, which would be really really influential, right, to the implementation of circular economy and circular construction strategies.
So that would be the first state level, broader geographic area that would be adopting a circular construction related policy.
Yes and no. That it really depends on the type of policy. California has several interesting waste bills, for example, at the state level that are much more far-reaching than what New York State has at the moment. So that it's not as easy to answer this question. It's not a yes and no question. But I think in the complexity that we're trying to address this topic at the moment, this would be unique in the US.
So I saw you present a little bit ago, and I just remember these images of flying panels, which were part of your deconstruction approach. So maybe you could explain a little bit what deconstruction actually means, because I just thought it was fascinating that it almost looked like a construction site when you look at panelized buildings, but you took it the other way around. And I think what's really interesting about it is just kind of the shift in thinking about how you build and then also unbuild, like that it's actually very similar in a way. So can you explain that a little bit more?
Of course. So deconstruction is essentially an unbuilding process, building in reverse. And the goal is to salvage materials at their highest utility and value. And so there are different strategies within this umbrella term deconstruction, because unbuilding a building is the most successful in terms of circular economy principles, but it's also a timely and with that a costly process. It can take several weeks to unbuild a house when you're carefully taking every beam and every joist out of the building. And so the images that you just referenced of these flying panels is an answer to that, where we're sort of combining different strategies. It's called a hybrid deconstruction or a panelized deconstruction, where we, in this specific case study, basically cut a building into the largest possible panels that still fit on a flatbed truck and can be transported on like the normal municipal road network, to then bring these panels from the construction site or from the deconstruction site to a workshop, and then further process the panels in a controlled environment indoors in the workshop. And there's two advantages to this. One is that you're much quicker on the site. And that is one of the key parameters when you're talking to a client, right? They're going to say, well, the demolition takes me 2 days and you want to spend weeks and weeks on building this building. That's a barrier to implementation. And so if we were out after on day 5, we had the whole building deconstructed, and the client was pretty happy with that timeline. The second component of this is that you have much more control in the workshop environment, and so the material salvage actually can be done at a higher value than if you're like balancing on a scaffolding in the height of of the roof, right? So that's another advantage. So there's a safety factor to this as well. There's a work environment factor to this. That deconstruction project, when we did it, we had 20 degrees Fahrenheit, so it was bitter cold. And so being out of that environment quickly and back in a heated workshop environment was another really benefit of a panelized deconstruction. On the other hand, of course, you're losing a little bit of material value because you're making these cuts. And so the design of these cuts is part of, I think, a really important step in the shift from sort of an unbuilding process to a panelized deconstruction process. And ideally, you know already what is the next use of these materials, so that you don't cut a beam that you then desperately need at 10 foot, but you cut it at 8 so that it fit on the flatbed truck, right? So the foresight, I think, is a really important component in the planning of deconstruction processes. What we're trying is we have our own tool within the Circular Construction Lab, which we're calling Scanner. Our tool is more kind of a 1 to 2 hour LiDAR scan of the building, and then get very quick estimates of material quantities to make better and quicker decisions whether a deconstruction is a possibility, to have a more informed conversation with a contractor about what material quantities would be in that building, or what kind of connection details you would, for example, assume this building has based on a building typology and a year build indicator. So very rough but publicly available data to have a first entry point into a conversation. Another interesting aspect that Scanner can help with is the permitting. So the city of Ithaca, for example, is really interested in the tool right now as a means to collect more data in the permitting process for demolitions and deconstructions, because something that I think all of these industries struggle with right now is the availability of reliable data. in Ithaca, we don't really know how much waste is being produced at a city level from demolition and deconstruction. And so having a much, even if it's quick, right, and even if it's an estimate, have a much better understanding beforehand would help make better policy decisions as well.
You know, it's so interesting when you were describing the deconstruction benefits. The advantages are so parallel with the advantages of a panelized approach to construction. You know, that you get to work indoors, that it's more predictable, and yeah. So I find that very interesting, and it made me wonder whether there are certain building types that are more likely to be cost-effective deconstruction process.
That's probably one of the biggest differences that we have between North America and Europe, because the majority of houses in a context like Ithaca and most sort of mid-sized American towns is timber, stick frame timber, balloon or platform framed, lightweight timber structures. And in Europe, the majority are cast in place concrete structures. And so there is a significant difference in how easy those are to deconstruct, with the timber being the much easier structure, because the connection details, even if they're not necessarily designed for disassembly, they are definitely disassemblable. And so also the panelization process is something that works easier in a timber structure where a normal saw could cut these panels, versus in a concrete building that is also the technology, right? The status quo in concrete deconstruction is also panelization, with large circular saws, and you're cutting through this concrete, but it is a much more difficult cutting technology than what we do here in North America. There are other aspects to take into consideration. One is contamination. So many of these houses have asbestos in them, have lead in them. That's probably something that we struggle much more in the US with than in Europe. And so a good abatement is mandatory for any of this work before you start. It doesn't matter if it's a demolition or a deconstruction. First, we need to get the contaminants out, because the last thing you want to circulate in a circular economy is asbestos fibers, right? So that is a mandatory step. And what we've learned is that if you're able to plan that abatement well, and if you're because of partnering with the company that does the abatement, then actually the deconstruction gets easier afterwards, because certain aspects are taken out already. But on the other hand, if that's not the case, and if the abatement is really just focusing on getting the asbestos out, there's also a lot of damage that can be done to material values through the abatement. And so it's really worthwhile having a good conversation with all stakeholders that are involved in circular processes.
So I'm still struck too by that image of the deconstruction going back into a factory basically, and just watching everything in reverse. So ideally, the ultimate circular or the ultimate circle would be those panels going back into a factory that just reuses components to make panels, right? But I'm pretty sure we're not there yet. And I know that in Germany they are setting up, with the help of the towns or the cities, they're helping basically to provide warehouse space to store deconstructed materials. Is that something that you are doing at this point as well? And do you ever see getting any support from municipalities for that?
Yeah, in the end, it's all about space. That's one of the key issues in the reuse economy. And you're completely right. We are trying to convince the state and municipalities to provide this kind of infrastructure or help support this kind of infrastructure. We're estimating that you probably need it at the county level. So a reuse hub at the county level, and that's a lot of reuse hubs to really build this economy. The only, or I think there's two that I'm aware of. The better known example is in San Antonio. So with the implementation of San Antonio's new deconstruction ordinance, the city also implemented a government or a city-run reuse hub in the city center, actually. So really nice location. And they're supporting this with, for example, a tool library. So anything that can help facilitate not only the storage, but then the reintegration of these materials into a new market can be bundled in this one location. And the idea is not that every material has to go to this place, but every material that a deconstructor does not immediately have a second purpose for can then go to this location and be stored there, and through the interaction find a new home. And so I think that is a really interesting example of how something like this can work on the city level.
That is really interesting. And what leaps to my mind is, well, these parts that you're taking out from older buildings, maybe from an energy efficiency perspective, not particularly useful. And, single pane windows that aren't particularly well made. I just wonder if you could talk about how to create energy efficient assemblies from deconstructed building parts, and or looking, sort of further ahead, what energy efficient assemblies should we be designing so that they can be reused?
Yeah, that's a complicated and large question.
Well, let's start with the first part.
So, I mean, you're right. So many of the materials that or many of the products, let's put it that way, that we're taking out of buildings right now don't fulfill code requirements for new construction. And the one that you pointed out, the window pane, is probably the most illustrative of those. And there are unique strategies of what you can do with single pane windows. One of the more beautiful examples that I'm aware of is by the Lendager Group, which is a Copenhagen-based architecture office that then started stacking these single pane windows and through that basically creating double and triple layered glass facades where you can see these different layers and how they overlap and create a new aesthetic while still fulfilling the code requirements, right? So there are ways through inventive design, right, to overcome these barriers and actually use the materials again in their purpose, which is I think the best use. And then, of course, there are other strategies where these window panes sort of don't necessarily find their way directly again into a housing purpose, but you start building greenhouses or other uses where the insulation value isn't the determining factor, but it is more about rain screen, for example, right? And there are many of these applications as well where you don't have to produce new glass for that because you find resources from reuse. So I think we're still in a time where we have ample applications that we can bring these materials into once they're deconstructed and salvaged. In terms of kind of energy performance and the circular construction, I think it's really worth to look at this always holistically. So neither only a performance indicator, I think, is the right thing, nor only an embodied carbon indicator can be the right strategy, but we need to look at both embodied and operational carbon simultaneously and come up with the most most beneficial strategies that work with both of these, right? And in the end, the solution for new construction is then probably a combination of salvaged materials and virgin materials, but these virgin materials need to come from regenerative sources, right? So if we talk about insulation, there's really interesting wood fiber insulation products, for example, on the market that you can then use to get to passive house standards, ideally insulating salvaged structural timber if you're allowed to do that in your state. Right now, there's only 2 states where you're allowed to build with salvaged timber, but I think that's something that is going to grow in numbers. And so you can have a regenerative source for the insulation. You can have the structural members from a reuse project. And in this combination, come up with a really unique and really low carbon strategy for the future. And then the last component is that you're designing that for disassembly, right? So that you're already foreseeing that whatever you're doing right now, be it in 20 or in 500 years, someone's going to take this apart, right? And so designing it in a way that it can be disassembled, that it can be turned into a product, be it a panel or be it a single material, I think is as mandatory as the use of salvaged materials right now.
What I just thought was really interesting about what you said, just picturing reusing the windows, layering them in 3 layers. I feel like it's such a great approach, but there needs to be a little bit of a mindset shift within that there's actually value and there's something good about seeing where materials or components are coming from or came from, instead of just always wanting to see the new and shiny components and materials. So I think that's quite interesting, and I feel like it's possible to get there, right? It's just kind of putting value into different places. I think one thing that pushes it along pretty well in Germany is also that there's just so much penalty by now with producing waste, right? So do you see that happening here too, that there's actually, you're coming kind of a little bit from the other side, where you instead of incentivizing, you're kind of penalizing?
Again, I think you need a good holistic set of policies that address all of these different moments in the life cycle of a material. And so, yes, of course, we can start increasing the tipping fees for landfilling. I think that's a mandatory step, and it would bring money into the pockets of counties in New York. I mean, waste legislation is different in every state and probably every town, so there's not a general one-size-fits-all solution to this, but it is a way to generate revenue that can then be reinvested into circular economy strategies, which I think would be great. It's also a way to disincentivize the generation of waste or incentivize the reduction of certain waste streams. I think something else that is should be mandatory in the US is source separation. Because the moment you're throwing it all into one dumpster, it's really hard, even if the goal is only recycling, and recycling really is the lowest of all circular economy strategies. But if the goal is only that, even then it's really difficult when it's been all mixed and mingled and crushed, to then separate that again and make value materials out of it and generate revenue from that is really difficult. And so if we're just separating wood and minerals and metals from each other, yes, we need more space on the construction side for 3 dumpsters. Yes, we need a little bit more time to separate it, but it's really worth it, not only for the environment but also for the economy, because it all generates labor and jobs, and so there's a whole other way of measuring the economic value of these strategies, which is actually something that is maybe even more convincing of an argument for reuse than many of the environmental benefits, is that it's a local strategy. It's hyper local. It generates jobs and value in the place where you're acting, right? Versus recycling is a global strategy that most of the jobs that recycling is generating are actually abroad. And the value is generated somewhere else. So I think that reuse is really a way to keep and retain value, social and historic and cultural and material value in the location where we are. And then in terms of policies, to just finish that earlier thought, so when we're incentivizing on the one side through waste tipping fees, for example, on the other side, a carbon tax would do the same thing with new products, right? So if a new product becomes more expensive because we're taxing the societal costs that are associated with the production of that, then that incentivizes reuse because that suddenly becomes cheaper in comparison. So I think on both sides of that life cycle, we have financial and political tools to change the attractiveness of these materials.
We've talked, mostly about single-family homes, but it's easy to imagine that, higher-end hotels or commercial buildings, offices are maybe not tearing down the structure, but are, constantly updating their interiors as to look better, or the use is changing in a building. Could you just talk about that aspect a little bit, and how maybe circular construction could be involved in that updating process?
Yeah, thanks for bringing that up. I mean, there's a huge percentage of the waste stream that comes from commercial upgrading, and it's not just hotels, it's also shop interiors, fit outs, it's corporate identities that need to be changed every time the lease changes, and we're pulling out carpet tiles to replace them with carpet tiles. And so there's a certain amount of madness going on in this space where materials that are just a couple of years old are torn out, and so to implement circular construction strategies in this space would significantly reduce waste, and it's probably one of the easier spaces to actually tackle because of the shorter life cycles, right? So one of the problems that the circular economy has when we talk about it in the built environment is that we're talking life cycles of 70, 80, 90, 100 years. And for a company to say, yes, I'm offering a take-back program for these structural columns in 100 years is really difficult, because, I mean, who knows if that company is in the 3rd generation still active in 100 years, right? But if we're talking about carpet tiles that are coming back in 5, 7, 8 years, this suddenly becomes much easier. And so also these materials, they have a little bit lower risk. They're more finishing. They're not necessarily structural or kind of the liabilities are a little bit lower. And so that is something that I would encourage wherever possible, right, to implement circular thinking and circular design strategies in fit out scenarios, especially in the commercial sector.
We've touched on so many different aspects of circular construction, and it's one podcast. I just wonder if, say, there were members of our audience, architects or builders, who wanted to dive into these topics a little bit deeper, but don't have a ton of time. Do you have any short courses to kind of educate people about just how to think in terms of circular construction in their work?
I unfortunately don't. That's something that we've been thinking about, but we haven't gotten around to producing courses yet. We do have a series of books which I could recommend, which are really dealing with the circular economy and circular construction. That's also the name. And so it's easy to find.
Yeah, and my last question was actually going to also be, what can we do? Because all of this just makes so much sense, and it has to go that way, right? We have to move into that direction. So how do we push this forward as an audience or as practicing architects, or what do we do to make this happen?
We shouldn't underestimate the sort of educational role that we can play as architects in the conversation with all of the stakeholders that we're interacting with. But then on the other hand, I think we also don't want to underestimate the shift that is happening right now anyways. I think increasingly clients and legislation are requiring a shift or demanding a shift. And so there's clearly something happening, and it's really good to be to ride that wave and to be to follow along or be in front of it. And so I just encourage everyone to take the end of use of a building design into consideration. It's something that we historically as architects haven't really been doing. We designed for the next 20 years, right? But and for the fantastic space that we're creating. But the materiality and what happens with that material at the end of use of the building didn't play that much of a design role, right? But I think it should. And so that's something that we can take into consideration. And with that comes then the question, what are we building with, right? Because then the moment we start thinking circular, we can address these questions at both ends of the design process.
So I think for me, the first big aha moment when I started hearing about all of this was really in terms of, practicing passive house architect, you look at assemblies all the time and you're trying to find the best products for your air barrier and all these components that you're using. And you really shift your thinking once you start thinking about deconstruction, because the moment you basically use a liquid applied air barrier, you can't use the substrate anymore. So, or even tapes, or once you start looking into mass timber, just fastening everything really tight instead of using all this tape or liquid applied products, really increase the worth of the reusability of these products. And that is something that we can do right here and now. And it's fairly easy to think about it that way.
Yeah. Or just get rid of spray foam. And anything that is fossil fuel based adhesive is counterproductive for the circular construction strategies.
Yeah. Well, thank you so much for all your insights. And I'm sure everyone has learned a lot and starts thinking about deconstruction a little bit differently. Thank you.
That's great. Thank you.
Yes, thank you.
And that was Felix Heisel. He is director of the Circular Construction Lab and also a assistant professor at Cornell University. Well, Ilka, you were sort of initiated this after hearing Felix speak for the first time. What were your takeaways from your chat?
So really, I mean, I think for me, this as a third interview to this series was just super interesting because we heard before from two Germans. I mean, Felix is German too, but he's been practicing here in the States. So we heard what's actively happening in Germany right now in terms of circular construction. And I thought it was just really interesting to see how we can relate that back to here to the United States and what we are doing and what we are able to do, like looking at policy changes and looking at research that he's been doing at Cornell and, just really seeing what is possible. And, I think it really comes back to a mind shift a little bit and really seeing materials that have been used as potentially being reused in the future. And, just really looking at it from that perspective is just, pretty amazing. And really, one thing that we talked about was also to look at deconstruction almost the same way as construction, where prefabrication is something that can be almost seen as a reverse effort. So that was something that was really interesting to talk about.
Yeah, I had in my mind when I was listening that vision that you often see of a prefabrication site with the panel moving in, flying in with a big crane, and then to realize you were talking about that, but in reverse, so the crane's actually taking the panel away, and it totally makes sense to do that sort of off-site deconstruction or panelized deconstruction, which I haven't heard of that before. Was that the first time you'd come across that, Ilka, or you seen that anywhere else?
No, that was the first time. And when I saw him speak, that was something that really, really stuck in my head. That image of this panel flying away and it being deconstructed instead of constructed, and just makes so much sense, right? And if you actually construct that way, having that in mind as being deconstructed, it's going to be so much easier because the process that he was showing was kind of, retroactively making it a panel that can be flown away. Yeah. But if you think about that before, that's going to just make that whole process so much easier and more efficient and cost effective.
Yeah, absolutely. Mary, what did you think?
Yeah, I mean, obviously that was really interesting, that part, and the safety for the workers who are deconstructing. Obviously it's safer and more comfortable to do it in an indoor environment. There were just a lot of positives, and I really appreciated that. Seems still a reach to have that happen here in the United States, but what I really appreciated was that there are some places in the United States where there's legislation in place to push along the deconstruction and circularity of construction, such as San Antonio, Texas. A little surprising to find it there, but that was great. Yeah. Great example.
Yeah, that's really interesting hearing about the various rules and regulations in different parts already starting to require certain levels of deconstruction or the ability for a building to be deconstructed. It'll be interesting to see how that grows. He did mention about how that impacts things like carbon and might be accelerated by the need to start thinking about carbon, embodied carbon, because this is, of course, a really good way to reduce that if you can reuse big parts of building elements. I thought it was interesting about the distinction between different parts of the building, and made the example of carpet tiles, which is one of the most common, particularly in commercial buildings, of being able to sort of replace those in a fairly short space of time, as opposed to big structural elements. And they're, some things are going to be much easier to reuse or recycle, or for the supplier to take back those components, whereas others are going to be a lot more tricky just because of their size, but also if it's a structural element, it's got to be it's still got to be very strong, and the consequences of that failing are going to be much, much, much bigger. So I thought that was interesting as well, that it's not just a one size fits all when you come to thinking about all the different components that are coming out of the buildings. And the other thought I had was about the role of architects in education. So towards the end, you talked a little bit about, and I get the feeling, because of Felix's various roles that he does have, he has this great opportunity to be working in research. He's doing teaching, but also has a practice as an architect, and I think that's it's kind of the ideal, because it allows you to stay current in practice, but also be involved in spreading your ideas and teaching the next generation. I guess that's something that you've had some experience in, Ilka, with your various hats that you wear from time to time.
Yeah, I think it's so important that you don't just do one thing, that you stay, all the research that you do and the academic side, I think is amazing, but it makes so much sense to keep it connected to the real world to really make sure that it works and that it's applicable. And I think it's pretty great what he is doing, where he says, okay, the university, the research, the education that I do brings me that far, but the last bit where maybe the university doesn't have the right insurance, or just can't take over a project, that's where his practice comes into play and finishes it out to make it a whole project. So I think it's just a great approach to do it that way. And I thought it was really cool that he said we can't underestimate our role as educators or as teachers, as architects. So I think we should all keep that in mind. And if we believe in something like this, we should, bring it up whenever there's a way to do that, and just, make people think a little bit.
And Mary, I really like the fact that you asked about single glazed windows and what to do. I mean, that was just one example, but there are going to be things that we take out of old buildings that are no longer fit for purpose in their current form because they're old and standards have moved on. I think that's a really interesting challenge, Mary, that you probed about.
Right. I mean, it's interesting because the buildings that are getting demolished are generally old, and so what to do with it was great that he had an answer so readily for what to do with some of these parts of the assemblies that just, aren't up to today's standards and won't deliver the energy performance that we would like. And it sort of contrasts with the commercial buildings that turn over much more quickly.
Yeah.
Where, as you mentioned, for instance, carpet tiles, but other fittings within commercial buildings, it's interesting. There's kind of like both ends of the spectrum there. Really old buildings, and then materials that are not that old but have a high turnover. Yeah.
Interesting stuff. Very good. All right. Any final thoughts?
Well, I think it was great that he said you really have to look at it holistically, that there's not just one way to do this. I think we're not here to say everything in a building has to be reused and that's possible. I think it's more of, okay, where can we strike a balance, and where does it make sense to use certain parts of the building and where does it not make sense? So maybe windows in a cold climate, unless you find a really clever solution to add up like 3 panes of single pane windows, maybe that's not the right component to reuse in a new building. Maybe that there it makes sense to use the new component, while other parts make a lot of sense to be reused. And if we just increase the amount, if we can just reuse half of, what comes out of the building, that's already a big win.
Yeah. Absolutely. Now, Felix is a bit of a prolific writer, certainly written his own book, Building from Waste, and has contributed to other books, including Cultivated Building Materials. So you can search those up. We might put a link in some of those as well, because he's written on his experience working in places like Ethiopia, which pretty fascinating stuff. So definitely check out his work. Well, that's it for our special series on circular construction. We'll probably be talking about this more, I suspect, because some of the concepts that we've talked about around deconstruction and reuse of building materials, not just recycling. I think we're going to see more and more of this. So really interesting stuff. Thank you very much, Mary and Ilka, for all of your interviews in this series. I've really enjoyed it, and started to challenge our thinking and not just the here and now of what we wanted to do with low energy, low carbon buildings for today, but also thinking about how we're going to treat those at end of life. We don't have any particular events to plug at the Accelerator this week, because you all are taking a well-earned holiday, I think, in summertime. But we'll be back again next week on the Passive House podcast, and you can check out lots and lots of really good content and videos all over at Passive House Accelerator. All right, thank you very much, both. We'll talk to you again soon.